the 2015 question 12 mechanics. We have a downhill skier, state Newton's second law of motion. So that's very straightforward. Newton's second law of motion is that force is proportional to either the rate of change of momentum or force equals mass times acceleration. Now, the key word there in the next one is a downhill skier of mass 71 kg. So downhill, travel the distance of 400 meters. Now, we don't actually use that 400 meters for the rest of the question. On a downhill ski course, her loss of elevation was 90 meters. That's the key part there. It's the change in height. What is the principal energy conversion that is taking place as the skier travels along the course? So, ignoring the fact that they may be accelerating themselves by using their arms to push off the snow, what they're looking for here is that the gravitational potential energy is converted to kinetic energy. So, they start off at rest, downhill, they speed up. So they have gravitational potential energy at the start, and then that's turned to kinetic. Now, ignoring friction, calculate her maximum velocity as she travelled, or when she has travelled to 400 meters. Now, so at the start, all the energy that the skier has is gravitational potential energy. By the end, all of that will be converted to kinetic energy. Now, her mass is the same on both sides, so we can just get rid of the mass. Acceleration due to gravity is 9.8. The change in height is 90 meters. And that's equal to a half v squared. Now, so just getting v in its own. Rearrange that, so take the 2 across and multiply. So 2 multiplied by 9.8 multiplied by 90 equals v squared. And then instead of taking squaring v, just take the square root of the other side, and that gives you her velocity of, rounded to the nearest whole number, will be 42 meters per second. And the next part, she then ploughed into a snowdrift and came to stop in a time of 0.8 seconds. What is the force that she exerts in the snowdrift? So, the snowdrift exerted a force on her, and she exerted a force on the snowdrift. Now, the force, Newton's second law, can be written as the rate of change of her momentum, which is mass times v, divided by the rate of change of time. So basically, the change in her momentum and the change in her time. So initially, her momentum will be her mass, which is 71, multiplied by the velocity. So just at the bottom of the ski slope, she is 42. So it's that change, and then that's divided by the time that it took her. It took her 0.8 seconds. So plugging those values into the calculator, so 71 multiplied by 42 divided by 0.8 gives you 3,727.5 newtons, because it's a force. And what force did the snowdrift exert on her? The same. Okay, because for every force there's an equal and opposite reaction. So it's 27.5 newtons, but in the opposite direction.